discussion. I mean, I don't regret missing the volatile session at all. So, yeah. Oh, here, yeah. Okay, Tim, go ahead.
I'm going to make a comment or ask a question that I hope doesn't pick a fight between Carly and Ian. So I want to square two things from your presentations. So Ian, one thing that really surprised me from yours is that you said that in your model, the way you have things laid out, the geometry, you'd end up with a zero magnetic field at the surface. And I assume that would prevent any kind of magnetic sorting, or is that not a good assumption?
No, it's not necessarily a good assumption because that's just right at the very surface, and that's also the total, that's right at the surface. There must be some magnetic field slightly higher up because that's what's influencing the plasma flow for any of these models. It's just this weird thing that when you get very close to the surface, in some parts of the anomaly, the field to total field does drop to zero.
What are any magnetic sorting process, though, is going to be in the top few millimeters or centimeters above the surface, right? I'm
not sure. That was one of the things I wanted to chat with Carly about, actually. And there, your point is well taken. There could be something there. It's a good point.
I mean, is that something that can be done theoretically, or does it need to be done experimentally? How can we know what the upper centimeter or two of the surface is magnetically? Well, at that scale, the scales of the model I was presenting were kilometers, and so at the smallest scales, the field could change a little bit. So you can't really know. I suppose. Well, I'd like to poke at this a little bit too, because Reiner gamma is such a huge, obvious shape, but it has all these others. And many swirls have much finer structure and nothing that's so regular as Reiner gamma. So whatever process we want to understand from Reiner gamma has to be able to go down to less regular and probably weaker to create the finer structure, which is so common. But I don't know how to even address that with the magnetics.
Mm-hmm.
Does that mean it has to be deeper or smaller, magnetized?
Yeah, I think Carly and I need to have a conversation and share our ideas. Yeah.
A properly instrumented rover could probably tell you a lot of what you want to know. Right?
Yeah, sure, definitely a fan of that. Yeah.
Okay, Bill Butke.
So there was a paper a couple of years ago, and I forget who the first author was. It was Mark Wazorek or Sarah Stewart or Ben Weiss or one of those people. But they made some arguments that a lot of these magnetic anomalies could be ejecta from South Pole Lake and Basin. Now, I don't know where that stands at the moment, but given that you've been probing Reiner gamma, do you have any thoughts on that? On whether that's a plausible mechanism, or is that now more doubtful? What do you think?
Is it a question for me?
I guess you were working on formation, so I should ask you.
Yeah,
but I mean, it's a group question, I guess.
Okay, great.
Do that.
Megan, do you want to?
Yeah, so we were considering the idea that it could be ejecta, but we definitely haven't gotten so far as to say like from which impact it could be ejecta from. So at this point, I can't really say.
Okay.
One of the I'm not a magnetics person, but one of the things I've learned from these guys and Ben is that, and Mark, that you not only have to have something impact and metal helps, because just as you mentioned, to give us the kind of strengths at these unusual, I think that's to pose, all these issues then start bubbling up again.
I think a lot of that paper, there's a lot of interesting things in that paper, but I think the link was using Sarah's model of the ejecta of SPA, seeing where it goes and saying, hey, there's kind of an association here.
Yeah.
And you can argue about that, but that just made me curious about, it's always a little bit hard to link something on the far side to something on the near side, but you guys have been thinking about it, so I thought I'd ask.
Let me give you a little bit of mind random walk, looking again at Reiner gamma, where you've got this very regular area, and then you have all these other extensive, that to me,
and it has to be buried because the surface is nice and smooth. So I don't know how deep, but it has to be buried, whatever the source is. But to get all these less regular and wispy interaction, it seems to me that whatever was emplaced or originated and went through its Curie point and captured a magnetic field, that there probably was impact processes later to reorganize these things to give the kinds of patterns that are less regular than Reiner gamma hit. But, you know, we can't undo that puzzle. I mean, we can't put that puzzle back together. Does that make any sense?
Sort of.
I will say, I think that if Megan's observations say that the tail may have formed during Mare volcanism, because to get that negative Bouguer anomaly, one of the ways to get that negative Bouguer anomaly is to deposit Reiner gamma on top of pre-existing Mare, so that's kind of a subtle thing in that model. But if that's true, that would probably suggest it formed after the South Paleocan Basin, if the South Paleocan Basin is old. So
that's kind of, well, I mean, we can talk offline about this, but that's kind of was my thinking too, just because most of the near side, even if you account for like the buried grail structures that Alex Evans has been talking about, seems like it's younger than the far side. And that would seem like you have an age contrast between SPA and those terrains. But I don't, but on the other hand, it's, there may be subtleties there, so that's why I thought I'd ask.
Well, let me ask you magnetic people, because it is such a strong magnetic anomaly, assuming it's not a recent commentary, just the fact that we have these magnetic anomalies, doesn't that require that whatever the carrier is went through the Curie point during the dynamo? I mean,
yes.
So that has to be some link to when the actual magnetic field was formed. That's on the assumption that it's not commentary, but so that gives us some window.
Mm-hmm.
But that window could be from 4.25 billion years to what? Is it now down to like 3.5 or
3.5 or 6, yeah.
Yeah, so it's a billion year window, right? So,
Yeah.
I mean, it's not zero, but it's pretty broad. So,
Yeah.
So, okay.
Okay, so just in the interest of staying on schedule, I'm going to cut this off for now, but we do have another potentially longer discussion section after the break. So we'll take a 15-minute break and we will resume at 11 o'clock. And let's thank our speakers again for a really great session.